So for not spending more my time, I'm going to present the first and the only opponent today, the conference of the name not available because he has problems to come in the conference. So he is Joan Antonio Barceló Álvarez, professor of the Autonomous University of Barcelona, a full professor in the area of prehistory, but he is much more than only this area, because he is also doctor in philosophy and archaeology, history, but he is now one of the most important researchers in this computing application regarding all the things that are about the archaeology and so on. One of the probably the most important person in the Iberian Peninsula in this regards. And some of my companions, when I speak about this professor, he told me all the time, like, okay, he's doing things that other people can not imagine try to do in their life, because it's quite complex and really interesting. So I'm here to learn at first. I think that would be really interesting for all of you also. So whenever you wanted, Joan, the floor is yours.
Well, thank you very much to Pedro for his invitation, and to the University of Cadiz, of course, also for organizing these meetings, online meetings, of course, but in fact, it's a way of exchanging information, opinions, etc. Well, let's begin with the idea. I have a problem now.
No se ha visto bien.
Oh,
No sé.
because I cannot see the presentation.
No.
I begin again.
Okay, try it again.
And I think now it will be. Yes, I think now we can begin. Well, the idea is to present something not exactly related with classical GIS things or special things, but the very concept of simulating the past and how to integrate space and time in this kind of computer-based visualization. Let us begin with some general, if you wish, philosophical or epistemological ideas that the past is too far away from us, so far that we will need a time machine to reach it. But, you know, traveling to the past is possible in the cinemas, in streaming shows, but there is no way of actually going back into the past to test a historical hypothesis.
Sorry, John, but I already see this, and I don't see it in full
No?
screen now. No.
The only way will be like this. Do you see?
Okay.
Yeah,
Okay. It will work like this.
yeah, it works.
Sorry.
Okay, no, thank you very much for making this call. Okay, we say that there is no way of actually going back into the past to test a historical hypothesis, and then we are left with the idea of imagining the past. That means that if we cannot enter really empirically into the past that once existed, we can enter into a virtual past that we have or we need to create artificially according to what we know for certain about such past. These virtual worlds are usually created using narrative language. We write a history about story, we write some text, and we explain things, events that may have happened, but always with uh, literary language and narrative techniques. The question will be, can we build an artificial past analogous to the real one that existed and using really images? Of course, in this case, computer-based images. In a way, this is what we do with so-called virtual reconstruction or virtual worlds. But we want to go well beyond what is virtual archaeology or digital archaeology. We want to simulate human behavior, human ideas, human decisions to understand how human society changed yesterday, changed now, and will change tomorrow. What I'm insisting something very, very typical, very classical, the idea of modeling the past, and models are ubiquitous around us for fast anything, for fast any domain, and they exist in many forms depending on the mode and vehicle of representation of the particular relationships we want to show here. Of course, every model is a wrong model in the sense that it's an oversimplification of some aspect of reality, but in a way, it makes emphasis on specific aspects of this reality and constitutes a way of understanding part of the reality. We cannot substitute reality with a model of reality, but it contributes to understanding things. And because there are many different kind of models, depending on the language we are using, here I want to speak about using not only mathematics, but some languages related with maths, like means probability, like means computer-based visualization, that means different kinds of computer programming. So let's do it. Where we began with this simulation of the past, and of course, we know to front the very definition of what is past, what we understand as a past. The questions will be what is time, what is space. This is a kind of questions that we archaeologists were using every day, but we are not giving a formal definition of that. And the easy answer is that both time and space are not things to be represented, but measures of something. Time is just the rate at which a system state change, whereas space is the location of the system whose state change we are studying. In that sense, a location is a member of a set whose identity is determined by how far it is from every other member according to it. From this definition of time and space as measurements, it emerged a very important concept, the idea of distance. And distance is just a function, that means the assignation of a number indicating an intensity of something, and this kind of function, or the number we are assigning, is just giving some idea of the identity of some different property. As a consequence, we have two different kinds of distances, temporal distances and spatial distances. In the case of temporal distance, it's a particular relationship between space and time through the idea of velocity and the speed we change space. That is the very idea of time. And the idea of space, more or less, is also related with the idea of changing location and the extension of the area behavior takes place. Why this matters? Because we want to study social change. And space and time are essential because every social process happens somewhere and somewhere. Space and time defines the relationship of an event with any other event. And of course, when we are trying to investigate social change, it's not just a single event of change, but plenty of different actions, activities, operations, decisions that are produced by different humans at the same place, at a neighboring place, at the same time, well before or after a determined event. This relationship between events can only be investigated through space and time change. But another aspect that is also very important that any historical research should relate the present of the historian with the past being analyzed. For too many times, historians, archaeologists say, well, this is very, very old. But we don't know exactly the distance between the act of observation, the present of the historian, of the archaeologist, and the facts, the events that should be explained. Is too far away, is too near, in which way the distance between the present of the archaeological explanation and the events that happened in the past are connected. It's important that we measure this temporal distance. It's important to consider time as a parameter and not as a mere label, as where we are working with periods or phases or some kind of frozen intervals of time. This discussion can be related in a way with the philosophical and physical discussion between Newton and Einstein about absolute time and relative time. Emic time, if you consider the definition of emic investigation, is relative. This is the time experienced by past social agents themselves. It's shaped by their own calendars and forms of experimenting change that people in the past may have. Emic time captures how people in the past understood change and sequence. Ethic time is the time used by historians. It's analytic time, and therefore it's also is absolute in the sense that all historians should agree on the way of relating events. We need this kind of absolute framework in order to build explanations about how events succeed and how, in the case, the event affects, contributes, or constrains a subsequent event. These questions seem to be too far away for a traditional way of doing archaeology. And the idea of this talk is trying to visualize the spatio-temporal historical dynamics. Where do we start with that? We start with a definition of temporal event. That is our unit of analysis. And we define it as a bounded, identifiable occurrence that marks a discernible difference in the state of a system or entity before and after it takes place. Of course, this is if you wish, a block of time, but it's an occurrence, something that happened. It's an action, it's an activity by humans, natural, by animals, by nature, but is always identifiable and has some very specific boundaries or limits. In a way, it's the minimal episode of change or transformation that we can observe. In the case of historical events, it's the concrete occurrence of a social activity or a singular activity, things that happen, human activities that happen. performed by social agents at a specific place with some motive and by means of some operations and under determined conditions. Even in the case of cultural heritage management, there is a definition of the object. It is defined as a change of state in cultural, social, or physical systems, like a birth, battle, or carving rock art. An archaeological object is an event. In fact, it's different kinds of events. There is an event of production. There is probably an event of distribution, how this object arrives to another social agent different to the producer. And finally, there are some events related with the use of this artifact until the event of its discard and its transformation into archaeological record with a different event that is the moment of archaeological excavation. In the case of archaeological events, there are too many different ways of defining the minimum analytical unit in archaeology, and we intend to understand archaeological event as the minimum observable discretization of the formation process of a site. It's not exactly what Harris say is a stratigraphic unit. It's the minimum unit of analysis when you try to discretize the formation process of the site. In a way, it can be compared to depositional events in sedimentology, where sedimentologists, geologists, define depositional events as single finite episodes during which sediment is accumulated. But in archaeology, it's not exactly the same thing. And I intend to relate the idea of archaeological event, of this minimum spatial unit or spatial temporal unit, with occupational floors, the surface upon which human activities occur, encompassing both visible structure like hearths or any kind of indirect features such as traces of former walls, etc. But occupational floors are not always easy to recognize. If you're excavating an archaeological site with sedimentary matrix made of sand, it's very difficult to discretize the process of sand accumulation. We need, in a case, microstratigraphic columns. We need a high resolution spatial analysis where you're analyzing the very, very close proximity of any kind of artifacts, and specifically of trash discarded materials, even at a micro scale. And once we know the geometrical limits of these units in the archaeological site, we should not forget that we should link the archaeological event with some historical events. That means which kind of human action is related with discarding these objects, with the construction of this wall, of the destruction and taphonomical degradation process of this built structure, etc. Only when we know exactly what the kind of social activity that intervened in the formation of this archaeological unit, then we proceed to the measurement. That means answering the questions: when happened, where happened. There is no secret that measuring with high precision space is relatively easy in modern times. You have plenty of equipment, GPS, total station, some kind of drones, satellite imaging. We have computer programs. We have very standardized ways of describing the geometry and the measurements we take on the field. Measuring space is not a real problem. However, there are still plenty of inertia accumulated problems like archaeological charts that are still organized by city terms or the definition in very ambiguous place where we don't know exactly the spatial coordinates of a particular site or a particular feature within a site. There's a huge literature on spatial analysis in archaeology, and I don't want to make more details about that because it's something that all of you know perfectly well. The study of archaeological time is not as relevant. Of course, there is plenty of bibliography, but very qualitative thing that they are still relating time with time in philosophy, with MacTaggart, with Heidegger, with a classical way of considering emic time. But remember, time is a measure in the same way as space is also a measure. And we have a particular clock, radiocarbon, in the different kind of radiometric clocks we can use, like uranium series, like paleomagnetism, etc. I focus on radiocarbon because it's the most extended way of measuring time for any historical event that happened in the last 50,000 years. That means we have a clock. Then why still rating on the magical number three in archaeology? Remember, we have three epochs. That means Paleolithic, Neolithic, Metal Ages. Within the Metal Ages, we have three layers, like Chalcolithic, Bronze Age, Iron Age. Within Bronze Age, we have Old Bronze Age, Middle Bronze Age, Late Bronze Age. In Late Bronze Age, we have Late Bronze Age 1, 2, and 3. And Late Bronze Age 3 have 3A, B, C. This is not the proper way of measuring temporal distances. In fact, 21st century, we should forget, beginning to forget, this way of describing time. The idea for expressing then space-time will be three standard measurements of space and one standard measure of time with some date error and the presence absence of some particular properties. That means each property will have three spatial coordinates and one temporal coordinate. However, the situation is not as easy as that because human events, even natural events, cannot be reduced to a mere dot in a map because we have in front of the problem of spatial extension. Archaeological events can express an area of particular size. The easiest solution, you know, from GIS will be different kind of buffer zones around this kind of points. This buffer zone is probably express some idea of extension, but also of uncertainty in the proper location of the ancient activity. Some cases, the spatial extension of the archaeological event is very large, and then with a very symmetrical buffer is not enough. And we have to define the area with all the different vertices around the irregular polygon that may define this area. It will be a list of vertices or the coordinate pairs and optionally uh, height, height preference also to define the boundary of the polygon. So sometimes we can define some kind of outer rings, inner rings, different polygon closure and order of data. Temporal events have also the same problem. It's even worse because the kind of human behavior that we should take into account is not produced just in a second, but it will have a kind of temporal duration, some days, some weeks, some months, some years even. In that case, for any archaeological event, we need to define the start of time interval and the end of the time travel. An additional problem with radiocarbon, with with its metric measurement, is that start and end time, the boundaries, are fast, always uncertain, and we cannot represent them with a single score. So there are plenty of mathematical techniques we should take into account that are referred in general as binning boundaries. That means that our duration interval has also some kind of confidence intervals for its start and its end. It's not the same, something that I try to remember to my students always, radiocarbon date as expressed in the laboratory report or after calibration is just a single interval of confidence. If you want to calculate duration of events, you need more than one date for each minimum spatial unit. When you have more than one, then you can define boundaries and define the particular probability uh, function, the probability density function of each of these boundaries. So this is the general structure of our archaeological data. We have three spatial coordinates, we have a geographical buffer in general, and we have a start time and end time, which in their turn, this start time can has an interval duration. Well, now we know how to formalize temporal information in a spatio-temporal model. But how we can use it? First, we should consider that spatial information in any kind of spatio-temporal model is always explicit. That means in our database, we always have the specific location at the most precise way of the archaeological feature we are investigating. Time can be used in an explicit way. That means when we introduce exactly a date, the beginning and end of a time interval, or can be emergent. That means in that case, what we are introducing into the model is a cycle. That means the behavior of the agents with the model uh, reproduce some kind of cycle of activities. And is the particular cycle which impose time and time duration to the analysis. In that sense, you are not introducing time into the model, but you can register time as a consequence of the functioning of the model. There are three main types of spatio-temporal models. Each of them, they are the advantages and limitations. The first way will be the equation-based models. The most classical ones are the reaction diffusion models. We have the agent-based models, and finally, social networks. In the first case, the equation-based model, this is just the most classical spatio-temporal model we can imagine. A reaction diffusion model analyze how agents, for instance, human populations, spread and evolve over time. The systems combine local reactions with diffusion to model a complex phenomena that more or less they are considered as people movement, for instance, or people exchange, cultural change, cultural interaction can be easily modeled with that. In most equation-based social historical models, time and space are explicit independent variables, structuring change through continuous or discrete update rules. That means for this model, you know for each archaeological event its spatial location and its temporality, its location on the calendar scale, even if this event has duration and you know the start and end of it. In that case, then you are running the model, and the result is a kind of emergent property of discovering some kind of regularity spatiotemporal regularity in the spread or the expansive moment you are studying. Plenty of examples, particularly on the expansion of early farming in the old world, from the places where farming where was essayed for the first time, the Near East, until its arrival to the Atlantic shores. A second type of model is the agent-based model, which is a computational model in which a system is represented by many individual agents. And each agent follows some simple rules. Of course, you can introduce any kind of rules you wish, but if your agents are too complex as the world is, then you cannot understand the behavior that may emerge. The idea is to create a simplified model where some kind of, for instance, prehistoric farmers began to interact with them or with hunter-gatherer societies, and as a result of their interest in surviving, they're finding some kind of social and economic solutions. One of them can be migration to new lands and the expansiveness of the phenomena, or some kind of cultural drifts, or some kind of cultural transformations. In those systems, time doesn't exist. That means that you are fixing just a setup condition, uh, initial context in which you say, well, I begin with the year 2000. And at that moment, there were this kind of households, this quantity of social agents, they had this kind of technology, etc. And you fix the survival cycle for agents. Agents should produce resources for surviving. These resources are produced. That means that you need to have previous resources for farming, for instance. You need instruments, you need seeds, you need fuel, you need wood, you need some elements. And those elements has been obtained in a previous execution of the cycle. And then this is a question of repeating the cycles. In general, we are trying to work with cycles reproducing the economic year. In this kind, well, in winter, we began with the exhaustion of resources. In spring, we are beginning to make cultivation, waiting until summer arrives and we can obtain food. In this period, we're still consuming some resources that have been stored from the previous year, etc. Within this cycle, there are plenty of agent interactions. That means a single agent cannot survive by itself. It needs some kind of cooperation with other agents in plenty of different things. You can create an agent-based model just with some kind of economical rules, but also social cognitive rules if you wish. You cannot cooperate with anyone. You should cooperate with something from your culture, someone who share your language and your values. For instance, if the neighbor has doesn't speak your language or has a different culture, maybe it's an enemy. Then you should prevent for stealing. You should make some violence in the case that your survival is at risk, etc. All of this can be introduced into the model. When you execute the model, you can transform the repetition of cycles into a calendar. And then you can obtain some kind of well-dated temporal events for posterior analysis using, for instance, equation-based models or reaction diffusion models, as we said before. The third type of spatiotemporal model are social networks. A social network is also a set of actors, people, groups, institutions, but they are not related by activities, but they are related by single channels. This is, in fact, if you wish, a kind of preludium to an agent-based model. because you can obtain different kind of links or channels of interaction, different kind of relationships, friendship, communication, influence, power, exchange, etc. And you can build different kind of networks depending of the type linking different kind of agents. Of course, you can work with collective agents, a family, a household, or individual agents, an individual, if you need to simulate that. Defining the topology of a social network means specifying how nodes are connected, which pairs of actors are linked or not, whether ties are directed or undirected, weighted or unweighted, if our power relationships, for instance, they're clearly related in a model. Some other ties cannot be really directed because they are more or less reciprocal, etc. And then a global pattern emerge when we quantify the number, the nature of the agents linked in that particular way. And we obtain some kind of structures called lattice, small worlds, or scale-free or modular clustered networks, etc. The topology encodes the network's structural shape and meaning. In network models, we can introduce time explicitly or emergently. In explicit time, we are building diachronic networks. That means we create a different network for different temporal steps, one each century, for instance. And then we can compare how the topology of the network change through time. And the other way, where we can encode potential time information being in the edges, in the links. Emergent time models are very useful because they help to reconstruct how processes may have unfolded dynamically on space in the past, because they explicitly represent the mechanism that generate social economic change over successive behavioral cycles. And the explicit time analysis, on the other hand, are excellent for testing some of the conclusions we take from emergent time models. When models are anchored in data observations coming from radiocarbon series, because we have this kind of external information, we can test whether the agent-based model or the emergent model has been well constructed and represents in a correct way the hypothesis we want to test. Well, as main conclusions of this presentation, what we are studying, in fact, are different forms of historical causality. That means how different events can be related. Some of them will be cause of other kind of events. Some of the events will be consequences of those events. To assess whether one event truly influences another, we should know the sequence in time and the spatial proximity and any kind of connection paths between them. There are plenty of work about the precise spatial location, but in archaeology there are still too much prevention to use specific measurements of temporal ordering. Of course, time is expressed probabilistically in uncertain terms using irregular time intervals. But mathematics allow us to process this information. An analytical representation of space-time let us see how events are located and related in space and time. And then we can visualize change. This is something very important. An analytical representation of space that lets us see how events are located and related between them. We can visualize using different kind of representations like vector maps, like multiplex structures of networks, or standard maps, where a kind of video imaging can show how a particular uh, cultural feature expands in this way. Here we are seeing the example of the expansion of early farming from the Near East when it begins, and its general expansion through different channels until arriving to the Iberian Peninsula, to the British Islands, and the Atlantic coast. Here, in this case, we're seeing how it may have expanded in the Iberian Peninsula. These are examples of emergent time, and we should test this expansion. And therefore, we can use this kind of reaction diffusion equation models to test whether the general hypothesis, the way we have defined the agents participating into the model, are correctly defined or not. Here you have some examples also of the use of social networking associated with space and with time. Look here, this kind of different networks at different time periods. This concern should move historians, and we archaeologists are historians, to think in the possibilities of ordering, comparing, and causally connecting historical archaeological events, and then aggregating all those events into different kind of conjectures, configurations, long-term structures, and then understand what may have happened in the past. Thank you very much for your attention.
Thank you to you, Joan. Really interesting conference. Now I give the floor to anyone who wants to say something, to ask, to add some ideas. Let me begin with your last idea about the historians. No, archaeologists need to be historians. No? It's a really important thing because I don't know, in conference and other stuff, you see plenty of analytical new ways to understand archaeological remains, but do not see so much how to understand these historical features, no, the historical events. It's like I don't know, for me, it's like a problematic, no? For me, it's not so interesting to see how we can. Okay, it is interesting how to know better this kind of ceramics, for example, or this new technique to understand involvement. It's important, but sometimes you go into a conference and plenty of people are representing their data, the archaeological data, but then you ask. Well, you don't ask because you are polite, but sometimes in your mind you ask them like, uh, uh, how or where or why, you know? The key questions are always there, no?
I think
So
that sometimes we archaeologists we don't think on problems to be solved, and we are still thinking on data to be expressed in some way. And then we are inventing using digital techniques just for presenting data. And someone will understand something if he or she wants to do it. I say that we have plenty of methods with a mathematical basis, if you wish, to describe data. Archaeometry is very interesting for that, but also for interpreting that. And the way of advancing in explanation is the idea of computer-based simulation. We can use one of these three different approaches: equation-based models, agent-based, social networks. But the idea is not just to express in a different way what we already know, but trying to understand what has changed. This is the real basis of the historical problem we want to solve with archaeological data. And sometimes, of course, because by law we should excavate, and once we have excavated, what we can do, beginning another excavation. And the archaeological material accumulates in museums or in storing areas. We write some wonderful monographs that absolutely nobody read. Why? Because I am interested in my own excavation. I'm not interested in your excavation. Until we think, no, I have to understand Neolithic, I have to understand Bronze Age, I have to understand some kind of Roman colonization aspects. And it's in that moment that we should read what the others have made and trying to integrate into something. And this something is not a database. This something is not a GIS system, which is just a database with a visual component. What we need are different ways of simulating what may have happened. And these simulations should not be black boxes. They should to produce some kind of data that contribute to some kind of validation and verification. Of course, there is always a model, and the solution is not the model, but the model is a step in the good direction.
Yeah, completely agree with you in this regard. No, sometimes you see like the idea is to do these pretty maps, no, these pretty representation of the foundings, but they are not thinking on the way. For me, it's like this kind of techniques is like an improvement on your own mind. No, try to see more, no, with this kind of issues. I don't know. Someone have something to say? If not, I have something.
Yeah, I have just one question. It was very interesting what you said. A special was interesting for me what you said about the cancellation of relative chronology using relative chronology and cancellation of the three periods IDs. Actually, what do you mean about those periods which where the radiocarbon is not working, and there is some periods for us? And are you imagine this regarding those similar cultures, like, I don't know, Bronze Age cultures, which are just appeared offset time from each other. So beginning in the, I don't know, in the Mediterranean, but sometimes in the 5 or 1,000 year appeared in the Central Europe. It's just examples, not exact cultures, but actually there are logically the same culture and the same and the etaps and the periods are logically following each other from the early phase to the middle phase and the late phase. But I understand, and it actually it's very logic what you said about introducing a very strict, I don't know, not relative chronology, and instead of relative chronology, a fixed chronology. But you don't afraid about that we will losing of that kind of parallelism, or the ability of the ability to compare one culture to the other.
Yeah, I think that the problem that we have is that periods are definite as some phases that have something in common, but this idea of something in common is not well defined. It was last week in a conference in Vienna that someone said, well, I'm still relying on the idea of period because if I have the same objects, they have to be the same time. say that is not necessary. There are some dishes from IKEA and that they're exactly the same as some dishes or plates from medieval ages. Um, Shape similarity, decoration similarity says absolutely nothing about the duration of a particular way of doing things. What we need? Well, to take all the archaeological context where some kind of object has been defined as similar, and then we can aggregate all chronometric dating of all those contexts and make a kind of Bayesian analysis and understanding this way of doing things has a duration of this kind of time. I am very critical about these periods that take duration of more than 500 years. Even in Paleolithic times, a community does not reproduce exactly the same way for 500 years. Then what we need? More chronometrical data and more geometrical descriptions of shape, decoration, provenance, or archaeometric analysis of any kind of materials. And then understanding, of course, maybe the shape maintains, but the way of producing is different. Maybe the decoration is the same, but the shape is completely different.
Yeah, okay. Okay, okay, that's part we agree. Okay.
We created a database of radiocarbon dates from all the world, and we end up with nearly 800 dates, 800,000 dates. I think now in the world there are more than 2 million radiocarbon dates. Of course, it's expensive to produce a radiocarbon date, but there are huge quantities, and many of them are of very good quality. What we need is to discretize the archaeological record, say, okay, this kind of pot, this kind of weapon, this kind of object, this way of building houses, and trying to integrate, calculating the temporality of this particular category in space and time. There are some potteries that they may have a chronology in Iberian Peninsula and different chronology in Central Europe. Bell beakers. Bell beakers appear in Iberian Peninsula. They don't appear very well on Balearic Islands, but they appear in Central Europe with completely different chronologies. And apparently, bell beakers are very old in south of Spain, but also very recent in south of Spain. What does it mean? Well, it's much more interesting the richness of information that we have bell beaker period.
Yeah.
A bell beaker in Britain, a bell beaker in Iberian Peninsula, in Portugal or southeast or southwest are similar, probably, but they are not necessarily contemporary archaeological events.
Yeah, okay, yes. Like
This is the thing what we need. Once you have the temporal event well definite, then you can compare and say, well, there are these similarities. Now we can begin to study why in different places at roughly the same time there are some kind of similarities. This is the way we are beginning to understand social dynamics, historical dynamics, and not saying, well, Belbecker, all Europe is connected at the very beginning of calculated times. For instance, this is a way of understanding, completely different of the expansion of Campanian pottery because of the Romans. And we say, well, there are completely different phenomena in different times with different kind of societies. And the integration of different social agents will be completely different. This is the idea of time GIS, what we really need. And people from geography, they don't help us Because if they're using some kind of time GIS, well, they're using historical data. It's very easy. That is 1869 until 1969, because they have some kind of very right and precise calendar dates. We don't have that. Of course, we should work with kind of temporal intervals, but they are numbered temporal intervals. And the specific distance from the beginning, the end, and the next interval is crown. If you don't know how old Bronze Age, you're, it's absolutely impossible to understand anything about social dynamics. When you are beginning to say that the expansion of early farmers from the Near East to the Iberian Peninsula took nearly 3,000 years, it's much more understandable that say, well, yes, Neolithic in the Iberian Peninsula, Neolithic in the Near East. Oh, but which is the temporal distance between both? This is the idea that we have to have some kind of time measurement. This is something that in archaeology we are not enough concerned about. What is strange, because we have arrived to this kind of concepts on the special things and the need to measure the spatial distance. If you remember that times on Renfrew, when he took just a straight line on a map as a distance. Now we have surface cost analysis, and everything, time to arrive to a specific place. This hasn't reached a lot the understanding of landscapes and the way we humans build landscapes. Why not doing the same with time? Maybe we need a bit more mathematics. Yes, because of the particular probabilistic nature of our measurements. Yes, but it's something that mathematicians say, well, but it's not so complex at all. It's just an irregular confidence interval. There is some kind of combination operation using Bayesian thing. And this is something that theoretically we learn at the end of middle school, how to sum or multiply probabilities.
Yeah, I agree. It's
My
we need more mathematics. We are full.
Any other question?
I'm thinking on the situation you're describing now, Joan. It's really interesting because, for example, for Roman times, it's like we have lacked, at least we have the information of the mentality of people. Let's say, we can more or less know in the time from prehistory is much more difficult to try to see that, and the chronology is really big. So even in you go older, more difficult. But I'm thinking on the situation of how this, for example, when you said this buffer, the distribution of the different materials, culture, people, in fact, maybe. Thinking on the issue of, for example, the question about the rupture and the continuity of things.
Mhm.
Because, for example, I was interested in that issue, especially when you see something different. When you see something different in materials or the archaeological remains, in fact, you are thinking all the time like in this rupture of culture issue of new influence from like the previous example, the oriental, the orientalization idea, how technology can. I was wondering how we can. Probably you don't know, but the issue is how we can one try to describe these kind of things, how to measure this continuation or rupture of cultures.
That's no problem. This is the advantage of measuring, because if you are measuring, then you are breaking the fate of continuity. In the specific case of the expansion of early farming in Mediterranean or in Central Europe, is the same. We know there is a very strong rupture when the early expansion arrived to the Danube Valley, and they stay at the southern shore of the Danube Valley for nearly 1,000 years. Why? But because we have measured, we know that there is a rupture there. And then it seems that it's the limit of wheat until they began to change the cereal. This expansion cannot regain. In the case of Mediterranean, we are now studying about seafaring and the possibility of navigation. If not, we cannot understand how these people from the Thessalia plain in Greece arrived to the shores of the Iberian Peninsula in 2000 years, more or less. Visiting before some islands like Sicily, like Sardinia, and the shores of South France. It's interesting to understand that they arrived before in middle south Valencia area, before arriving to Catalonia. That means that it's a navigation, but not exactly down by line of the coastline. And how we arrive to that? Because we can find ruptures, discontinuities. And the only way to understand and to discover this kind of discontinuities is having temporal distance in the same way as spatial distances. If you don't have this kind of measurement, everything appears to be continuous.
Yes, I'm thinking of this because in the previous talk, in the first session, let's say, we were talking about the issue about the demographical studies, no? How we can measure, no, the number of people, how we can measure this change. So it's also a diachronical aspect, no? And this is, we know, there are things that for sure we cannot see, no? It will be possible sometimes to measure with detail, no? But I was wondering about these mathematical approaches, about modeling, because okay, we have plenty of data, but as you told, the information, radiocarbon are expensive, so sometimes we don't have all the tools. So it's not a question; it's more a reflection, about how we can improve these kind of things. We are like the easy way to solve our question is like we need more money. We need more money and we need more money. Okay, but there is something that we can do it more efficiently in this kind of modelization, for example.
Yeah, for instance, there is a very interesting example in Neolithic in Iberian Peninsula, in northeastern Iberian Peninsula. We can follow from Magdalenian, where there is a strong population just at the end of glacial times. There are some good evidence of population in northeastern Iberian Peninsula and the beginning of the Epipaleolithic, and we arrive to around more or less the year 8000, and people disappear. What does it mean that people disappear? That means that we don't have archaeological sites occupied at that time. And this is kind of an interruption, very interesting. And we can ask, but this is a problem of archaeological surveying? Well, this is something that we can explore. Then we go to those sites where there are some occupation near Epipaleolithic and early or late Neolithic, and trying to understand the taphonomy of the site. We don't find any problem. We have arrived to date volcanoes because just in the center of Near Eastern, the area in La Garrocha around Olot, there are plenty of volcanoes. And we know that the oldest, the latest eruption of those volcanoes are around this time period. But we are discovering some sites just 80 years after the eruption. So we know that it's not a question only of environmental things. Of course, when we arrive to Middle Neolithic, it has been a research project. They have investigated all kinds of individual graves, and we have a huge quantity of dated context. It's not an expansion of population in the more or less the 4,000. We know there is a bond effect at that time, and there's a generalized crisis in all Western Europe in that period. But in Catalonia, we have plenty of dated context. What does it mean? Of course, here we have a problem related with sampling. There are much more investigation of this period than for the megalithic next cultural period. And it seems to be an expansion on a demographic increase. When we date that and we take care of the sampling things, and we are using some kind of what we call heuristic analysis for understanding the number of dated context, non-dated context, and spatial areas, then we can understand the biased effects of archaeological survey. But everything is the result of, first, the question. At first, it's always a question. The question imposes a kind of data, and of course, a kind of data processing, always to solve the question, not only to process the data. And I think that is what we lack, not only in archaeology, but also in most social sciences, in history, in anthropology, is the same. There is something that this has been created by the human, it's important by itself. No, it's important because it says something about what humans made at a particular place in a particular moment. And this is our job as historians to understand why people did this activity at that place and that time, considering what they did at the same place before or what they will do at the same place after.
Particularly either way. So anyone has something to add, to ask? Here is the more important thing is this debate, no? For me at least, because this is an opportunity to see in a more clear way all the methodologies and to understand the questioning. For me, it's really interesting how to do this kind of techniques. And for example, the using about the how we can, for example, see this rupture. I already told. Because, for example, when we see this expansion of things, when they change it, sometimes so there is a possibility to see these expansions without the data, let's say. Because sometimes the model is like, okay, we have these archaeological features, we have this analysis, and then I'm trying to understand what happens. No? But it's possible the other way around, let's say, to take data randomly and try to set up like for example the predictive modeling, when you try to see where will be another archaeological site like this, to see these kind of things. You try to do this way or not?
Expansive phenomena are the most, for me, interesting in archaeology. Why? Because more or less they are related with some kind of conflicts between different populations. Traditionally, Iberian archaeology has been full of expansive phenomena because ex-Orient looks without any kind of discussion about. Some people arrived with some new way of doing pottery. Some people arrived with some way of doing architecture. And everything was the consequence of something invented in the Eastern Mediterranean. Well, now we are beginning to think how these people arrived. We don't have a lot of depictions of Neolithic ships. We have some ships recovered in some archaeological sites, but most of them they are for river navigation. Now we are doing some kind of simulations for understanding how a Neolithic ship can be built to arrive from South France to the Catalan coast. It's one of the most dangerous seas in the world. Even the modern sailors, they say it's a Gulf of Lion is very, very dangerous. So it's not any kind of ship. But data say there is some connection. Which kind of connection? Similarity in archaeological things is not enough. So we should understand what does it mean to be same. Geometrical analysis, very precise analysis of the shape, of the curation. This is something that we are still lacking. Some good analysis, geometric analysis of decorative motifs. We're working on that using neural networks and the like. And of course, the help of paleogenetics, because paleogenetics give us data about human movement. But we have always the same problem. This is similar population is not have one biological marker exactly the same because of the implicit diversity, heterogeneity of any human population. Now there are plenty of discussions with just 3, 4 genetic analysis of individuals. The Yamnaya, we don't have enough information about the arrival of new populations to the Iberian Peninsula around the year 2005. And this can also be made in historical dimension. We're working now with some of the civil wars at the end of Republic times with the Romans to understanding how they arrive, the nature of the armies, which are international armies. So the politics comes from Rome, but the people arriving here come from the Gaul. It's not exactly the same. And this kind of precise analysis of using maths, if you wish, the expression, allow us to find delimiting the historical dynamics. If we are just using words, narrative structures, it's absolutely impossible to understand fast anything. This is the reason of the very low priority of historical disciplines among most people.
Okay. Yes, quite interesting the case. So, anyone has something to say, to ask? Well, thank you very much, Joan, for your presentation. Thank you especially, for helping in this opportunity to create the network. We are going to continue next in 2 weeks with Professor Andras Bodox there and Timon De Haas, that they are going to tell us something probably about their studies. No, we need to have the full title again for the next conference, the 24th, the next Friday, the next one. So thank you very much to all of you, especially to you, Joan, to be here.
Thank you to all, and it has been a nice talk, and until next time.